In this animation, we'll consider the diffraction and dispersion of light and the minimum deviation equation. Have you ever looked at a straw in a glass of water? From the side, it looks a bit wonky, almost like it's bending or breaking at the water's surface. When light passes between two mediums, in this case air and water, it changes speed, causing the light to bend. Thanks to the same effect, we get rainbows and halos. Refraction is the name for what happens when a wave passes between media at an angle other than 0 or 90 degrees. The rays of light bend. The index of refraction of water varies with wavelength. How much different rays refract depends on the refractive index, the ratio between how fast light travels in a vacuum and how fast light travels in that specific medium. The refractive index, n, is equal to the speed of light in a vacuum, c, divided by the speed of light in a medium, v. The refractive index varies with wavelength. Therefore, dispersion occurs. Dispersion refers to the separation of different colours of light based on their wavelengths as they pass through a medium. White light splits into its constituent colours: violet, indigo, blue, green, yellow, orange and red. When white light passes through a prism, the incident ray splits into its 7 constituent colours and then refracts again on the other side. The emergent ray emerges from the other side. Some colours bend more than others. Red refracts the least, and violet undergoes the maximum deviation. The angle of deviation is a measure of the extent of diffraction, defined as the angle between the incident ray and the emergent ray. A minimum deviation occurs when the ray passes through the prism symmetrically. We can relate the refractive index to the angle of minimum deviation by the following equation. N, the refractive index, equals sin of A plus delta, divided by 2 over the sine of A over 2. N is the refractive index of the prism, A is the angle of the prism, and delta is the angle of minimum deviation. Rainbows and halos are natural phenomena that occur at minimum deviation. When sunlight passes through water droplets after rainfall, rays reflect on the opposite side of the droplet before refracting again as they exit the droplet. The sunlight splits, creating a beautiful rainbow pattern in the atmosphere. A halo occurs when light refracts from ice crystals inside clouds, forming a ring. You might think that white light has a single wavelength, like other colours of light, but prisms make it clear that white light is in fact made up of a mix of all colours of visible light, each with a different wavelength. Let's practice using the minimum deviation equation. A glass prism has a refractive index of 1.52. The angle of the prism is 60 degrees. What's the angle of minimum deviation when red light passes through it? Substitute in the refractive index and the angle of the prism. Solve for the angle of minimum deviation. Apply inverse sine on both sides, and there you have it. The angle of minimum deviation for the red colour, represented by delta, is 38.9 degrees. We've covered diffraction and dispersion of light, as well as the equations for calculating the angle of deviation and the minimum deviation. There are plenty of questions on the Chegg website to practice using these equations.